I'm just going to say, hello, my fellow YouTubers. This is Roy back again. So, I was working on my mots and my Tesla coil, and things are moving along pretty good. I'm on day two, I believe, or three, probably day three. And the next thing we're going to do, we're working on right now, I'm building a better spark gap with the air blowing on it. And then also, I'm taking the bottom end of these mods, these primaries are right now in parallel, and the secondaries are in series. So that means, and before the way I had it is the bottom was in series and the top was in series. So to me, that was getting 60 volts here and 60 volts there. Okay. So the voltage coming out the end wasn't the 4,000 I thought. By looking at it, that's what it says to me. So now I have these bottoms in parallel, so they're getting 120 on each side, and the tops are in series. So we have coming out one end 4,000 volts. But I started blowing up my capacitors, and that's because using these micro breadboards, um, they're not able to hold that voltage. So I'm getting snap a bang of booze in the bottom there. So I'm gonna have to build me some capacitor banks because these are cool little capacitors. So I want to utilize them. I got tons of them. So two things I'm going to work on. Thank you for sending me that schematic of the Tesla coil. Obviously, it says 50 cycles, so it's obviously two mots going into two microwave um, capacitors. I believe what I'm looking at is that the microwave capacitors, since they came with the mot, are putting in resonance between the mot and the capacitance. Then I'm going to come out of each mot, so I go hot out on each one. So the secondaries won't be in series on this one plan that I seen. So forget about what I said in the beginning because I want to try that anyway. But in this schematic, it was a hot out from each. You go into one side of the capacitor, you come out the other side, and then you're going to go into the diodes that come with the microwave, and you'll have two diodes, and then you would have a safety gap from there, and then you come out, and I believe you're going to a air coil choke filter, and then from there you're going into a 1 nanofarad each capacitor, then to your spark gap, and then to your capacitor bank, um, out to your primary. A little different than what I'm used to, so I'm gonna have to try it out and see how it works. So far, I do like with the bottoms in parallel and the tops in series because you have one way coming out with high voltage. But I have always ran my spark gap out of the hot end of the capacitor through the spark gap to the connection of the primary, and always ran the back end of the primary either to ground if I was doing 7500 volts and only had one half of the NST running, which happened to me for a long time. Then I got me a new NST, 15,000 volts, 60 milliamp. So you run the other hot of the NST directly to the capacitor bank. So when I was using my capacitor bank being buckets, bottles, a bucket with bottles, each end would be a hot. So when the NST is doing its flippy floppy, one is always a negative, one's always a hot. Then it would shoot out, go through the spark gap to the primary, and um, back out of the um, back end of the primary back to the capacitor bank. Um, so there's many ways to skin this cat, and obviously coming out of these mots and going to the capacitors, microwave capacitors, and then to a dioid. Oh, and then to, yeah, the dioid, and then through some resistance. It's different. I'm not used to that, so I'm gonna tread lightly there. But I figure I'd take a break. Let's come over here. This is so damn cool here. I'm gonna call this. This is my connection between static and magnetism. I'm going to show you some cool stuff that I'm working on right here. And this is just me taking myself out of my own envelope again. So basically, you got a neodymium magnet here. It's hanging from the rafters, about 5 feet. It's hanging from this regular sewing thread, okay? So it don't have a lot of resistance turning. It can turn, sort of like Ed Leedskalnin putting a magnet in a spider web. It has freedom to turn. At some point, it'll have a lot of resistance, resistance. Um, but here's Ed's PMH. Obviously, it's just the iron bar. I've been charging it over and over so many times for the last 4 years that that shows me that this iron here isn't just iron. It has some steel in it, or basically we can say it has carbon in it. So I got a regular or a regular crescent wrench, and it barely but sticks. There you go. So now we have a keeper bar on. So now, obviously, if it's sticking, there's residual energy stuck in the carbon steel in the iron that's causing this magnetism. Now, as I put that keeper bar on, you can start to see the neodymium is doing a little gyrating, okay? Because now the energy is traveling around the bar. But let me show you something cool when you introduce some copper wire. So I got about 6 inches from end to end. This is like 28 gauge copper wire, and there's some obviously 1/4 inch thick PVC. This is green pipe, so it's sewer. So we're going to go ahead and start moving this PVC around. Look how it reacts statically to the, watch the thread. You're going to see the thread and the magnet react. And I'm never going to touch the magnet, but it's reacting. There it goes. I know you see it. It's reacting to the PVC or to the copper wire. See that? Look at that. Now it's pushing away. Now I want to let you know that the bottom of this wire is connected to this alligator clip, which is steel, alligator steel clip, copper wire, and then it goes up, and this is just the magnet. It's sticking to a magnet, which I have so many magnets up here. So there's obviously a lot of magnetism going on up in that area beside Ed's wheel down bottom. We won't get into that. Speaker on top of Ed's wheel. Another video. Wow, we're gonna show some sound along with some cool wavage I'll call it. So back to this. So this is sticking to the magnet. The magnet stuck to the iron. The iron goes down. There's Ed's pipe, which is like 8 feet into the ground. So there's your earth ground. Okay. Forget about the copper disc and I got and the copper going down. That pipe has nothing to do with what we're working on, but you can see it. And if you really want to take notice the triangle. There's some meaning behind that. So now we're going to go ahead. The bottom of this wire, obviously, we know goes to ground. So that means this conductor is connected to Earth. Okay. So now we're going to bring this in proximity. Now I want you to see. Look at that. Look at the reaction. There, I just touched it there accidentally. But look at the reaction. See it moving? Let's go ahead and just set this here, okay? So what do we have here? We got Ed's PMH. We got just this wire and this PVC sitting on top. Let's move that magnet. How are we going to move that magnet, guys? Let's go ahead and pull off. As we break the contact here, because there's energy running through this, right? Because it's sticking. As we break the contact, We're going to take